Okay, let's talk about exception handling. So, up until now, anytime that we had an error, what would happen to our code? It would just break, right? The only time we've ever done any kind of type of exception handling is when we would have to do a throws clause on stuff. So if you think to any time we had to do a scanner or maybe a file input or something, we had to do a throws clause. We never really knew what that meant, right? Well, we're going to learn what it means a little bit later. That's the only type of exception handling we've ever really done, and we didn't really even know how it was working. So what we're going to learn about is how we can handle these problems and either give the user some feedback, some more feedback onto what happened, how to fix it, or even allow our code to keep running even when we get an error. So an exception is an object that's generated as a result of an error or an unexpected event. The key thing, the key takeaway from that is the fact that an exception, which is a problem or an error, is an object. Let's look and see what that means. So anytime we were given an issue like this, right? So like, let me run this. This is an error, right? This error right there, that's the error that happened. A number format exception. That's actually an object that was created. I know that it's like, what do you mean? Well, here's what I mean. The object that we create, so look at this hierarchy. The object that we make, so the class that we create, inherits from a class called throwable, which we'll talk about a little bit later. That inherits from two other classes, error and exception. So let's break that down. So you're telling me that there's two classes inside of Java called error and exception. Yes. And they're created to handle these problems. That's how we get all that text, right? It doesn't just come out of nowhere. All that red text comes from somewhere. It comes from these classes. So the error class, if we get just a straight up error, these are what's called unchecked problems. They're critical errors. They're big stuff. So like out of bounds errors, out of memory. So like maybe you got infinite loop or something like that. This is stuff we can't really handle on our own. There's stuff that's just gonna break, and it is what it is, right? The other type is an exception. If it falls under this category, this is stuff we can fix or we can handle if we want to. That class exception, it's a super class for all the other types of exceptions, and there's a lot of them. Two of the common ones that we see are I/O exceptions. This would be maybe the input mismatch, right? Or maybe a file not found, or incorrect input. Maybe you asked for an integer and they gave you a string, right? That would fall under I/O exception. In that class, I/O exception, it has some stuff in there, like some messages that it could send back that explains what the error was. Or a runtime exception. That class can handle any kind of runtime exceptions. And inside that, it'll also have messages that it can send back that gives the user feedback onto what actually happened, right? And so the key takeaway here is that all these classes inherit from each other. That's why we're talking about this after inheritance, so we can fully understand how they're doing this. So when we get an error, for instance, it calls several different classes. It falls back on several different classes. The throwable class, maybe the exception class, which then falls back on the specific exception that happened, right? So how do we handle these? So if it's a exception and not an error, how do we handle it? We can handle it several ways. The first way we're going to look is called a try-catch block. You might have seen, if you've ever done any Googling, looked at some Java stuff, more advanced stuff, you've probably seen some try-catch blocks in there. Here's what it looks like. So what these do is, these are going to try to prevent our program from crashing by catching the error, sending a error message back, and then continuing on with our code. So the way it works is we have a try block here that tries to do whatever it is we want to do. So in this case, it's trying to convert a string into an integer, right? If that doesn't work, the catch block gets executed. When the catch block executes, it's going to print an error message out. Okay, we can have as many catches as we want. So we could have a catch for every type of exception that we could possibly get. So we can make a catch block for every type of error that could pop up. We can also attach what's called a finally block. This is not one we're going to do a lot of, but the way a finally works is, and this one isn't a really good example, honestly, a final block will run no matter what. So whether it catches it or not, it's going to run that finally block. The reason why this one's not a good example is because we don't want to say, please try again if it was successful, right? So the key thing is a finally is also optional. So you don't have to have a finally. A try block does need a catch. It needs at least one catch, but you can have as many catches as you want. A finally is optional, and a finally will run no matter what happens. Okay. Let's look at an example real quick, because I know that doesn't make sense when you're just statically looking at it. So looking back at this one, this is based off the example that was in the notes. We're trying to put an incorrect input into this method, right? So we want to parse an int, but we're giving it A, B, C, D, E, which is giving us a number format exception, right? That's the specific exception that we're getting. There's a class called number format exception, and it's sending back this information for me that this is an error, right? So what if we want to fix it? We can throw it inside a try catch. Here's what it would look like. So now this piece is inside the try. It says, hey, try this, but if you get this exception, I want you to do this, which is going to print out an error message to the user. Here's what it looks like. It says conversion error, e.getMessage, which actually prints this out for input string ABCDE. So this e.getMessage is printing out a little bit more information to the user about what happened, like what went wrong, right? You know now, before we were getting the red text, right, which was really hard to decipher sometimes. Now we're getting some really clear information as to what happened, right, Ray? Yeah. Okay, are y'all paying attention, or am I just talking to myself? Y'all falling asleep on me? All right, thanks for being honest. Okay, let's talk about how this works, the catch works. So like I said, exceptions are objects, right? It's a class. So when it catches it, I need to make an object of it. That's what that's doing. It's making a number format exception object, and the reference variable is an E. The reason I use an E is it's kind of a standard. It's just a default. I can make that anything. I can put whatever I want. That's just me storing that reference inside a variable to that exception. Inside that class, number format exception, there's a method called getMessage that prints out or sends back a error message, right? So if I do e.getMessage, it will send back this message right here that gives the user more feedback. Does that make sense? Sort of. Okay, going further, what if you don't know the type of exception that you're going to catch? Because there's lots of them, right? There's dozens. There's a catch-all. If you just put the word exception, it will inherit from the exception class instead right here, right? It won't go deep enough, but it'll determine which exception was actually, created, and it'll find it for you. So notice it printed the exact same thing. It'll find out that, oh, that was a number format exception. Let me go create that type of object and call its message, right? So if you're not sure which type it is, you can use the word exception as a catch-all. All right, let's look at another example. What if I had this one? Shouldn't have. So let me break it. So this is going to read from this file, right? What if I put in the wrong file name? What type of error am I going to get? A weird one? Well, this says file input stream, right? It's actually an IO error, right? An IO exception. See how it's IO? I probably could put file input stream in there too. But it's an IO exception. So if I want to catch it, I'm going to do a try catch block that does the same thing as the last one. So everything you're wanting to try, put it inside the try block. Do IO exception, because that's the kind of exception I'm trying to catch. And then print out its error message, right? So do e.getMessage. It says error, goodfile.txt. The system could not find the file. Notice how that's a lot more information than all that red text, right? See how this can be beneficial? Okay. Again, we could, if we weren't sure, we can catch any exception using exception. So maybe, I don't know, I could be going on a limb here. What's something else that could break here? What is raw data? An integer? Yeah, I broke it completely. Man, I can't think of anything off the top of my head. That's probably going to break too. Yeah. Oh well. But anyway, if it caught any other exception inside of here, that would catch it as well. I don't know if it would catch an out of memory. I don't think it would. So, but just know that an exception, that'll do like a catch-all. Wonder if this would work. I just want to try something out. If I read... Oh, yeah, I can't read it. What if I declare it up here? Oh, it doesn't like that either. Stick with me. I gotta. Oh, why would it not like it? It says int raw data right there. Oh well, I went too far. I should back it up. I'm getting too complicated. Y'all get the idea? The last thing we can talk about real quick, it's called a stack trace. This is the example that I gave inside the notes. So what a stack trace is, the book's going to talk about it a little bit. We're not going to do a ton of it. It's just something to be knowledgeable about. What a stack trace is this stepping that it does when it gives you the error. So these are when it's going to call multiple methods in a row, and it'll trace up until it gets to the actual error. So the actual error was an index out of range, which was this type of error, right? This index out of bounds right there. But this whole process here is called a stack trace. It shows you, hey, we started in the main, then we went to my method, then we went to produce error, which are all these methods, right? We called that one, then we called this one, then we called that one, and then that's the one where it broke, right? When we tried to do the char at. So a stack trace is a trace of all the methods that it tried to call before it got the error, which could, so we've been seeing these all along. That's what it's called. It's called a stack trace.